so here is our next to last lesson of the semester. I know, that is exciting, isn't it? Yeah. Okay, so what we're going to do today is learn a whole new way of solving systems of equations. So, yes, you're going to like it. So, you know how we can use graphing, but that's not accurate if your points of intersection or fractions or decimals or really big and off of a normal size graph. We can use substitution, we can use elimination. Today we're going to learn a new method called Cramer's rule. Okay, Cramer's rule. And there it is spelled right there. Okay, so what we're going to do is form a coefficient matrix. So in our system of equations, we're going to line it up like we normally do with x's, y's, equals, constants all lined up in a similar fashion. And our coefficient matrix will just consist of all x and y coefficients. Okay, so I'm going to take all x, y coefficients, translate them into a 2x2 matrix. Okay, so what we're going to do with Cramer's rule is we're going to find that determinant. And this is the first system that we're using down here in example 1. So let's find this determinant. I'm going to say x equals, and I'm going to set up a fraction, and on the bottom I'm going to make this determinant 1, -5, -7, 2. And I'll come back to the numerator in just a minute, but in the denominator it's just the xy coefficients. Okay, how do we evaluate that? What do? We did that yesterday. Start upper left, multiply across, and subtract the other product. So in the denominator, I will have 1 times 2 subtract -7 times -5. Okay, equals. All right, that's 2. That's positive 35, so that's 2 minus 35 is negative 33. Okay, if for some reason you got a 0 in the denominator, then that would tell me that this system didn't have a solution. In other words, they were parallel and never intersected. Okay, so what I'm going to do in the numerator for x, I'm also going to have a 2x2 determinant. But whichever variable I'm solving for, in this case x, think of the first column as the x column and the second column as the y column, just like they're kind of written over here. Whichever one you're solving for, you are going to replace those coefficients with the constants. Okay, so I'm going to write them in a different color here. Instead of the 1 and the -7, I am using the 9 and the -30. I'm still using the y coefficients. Okay, so whichever variable you're solving for in the numerator, kick those coefficients out, put the constants in their place. Still use the y's. Okay, well now let's simplify this. 9 times 2 subtract -5 times -30. Okay, well that's 18 subtract 150, and that's -132. Y'all check me on that. Is that right? Okay, thank you. And now let's divide that. Hopefully it'll divide evenly, but we'll see. 132 divided by 33 is 4. So my x coordinate is 4. Now, how can we find the y? Well, of course we can plug it back in, but I'm also going to show you, and I kind of ran out of room here, how to find the y. I'll have to squeeze it in up here. Okay, it will be a 2x2 determinant over the same exact one that we used down here. All the x and y coefficients. So I already know that that denominator is going to be -33. Don't redo it. But the numerator for y will use the x coefficients, but not the y's. The y's get kicked out, and I replace them with the constants. Okay, so then I'm going to take 1 and multiply by negative 30, subtract 9 times negative 7, and it's going to be over negative 33. Okay, so y equals negative 30 plus 63 over negative 33. And that will give me 33 over negative 33, which is negative 1. So my solution is, where was my x? 4, comma, negative 1. What do you think of that? Kind of cool?
Yeah.
Guess when it's even cooler. Remember how much y'all didn't like the 3x3s? Some of you? We can use Cramer's rule for that. And we can use our calculator to do the 3x3 determinant. So it's really quick when you get to the 3x3s. Okay, so let's do at least one more, if not both of these 2x2s, and then we'll look at the 3x3s. Okay, so I'm making sure the x's, the y's, the equals, the constants are lined up. We're good to go. I'm not going to take up quite so much space this time. 2x2 over a 2x2. Okay, the denominator is always x coefficients, y coefficients. X is your first column, y is your second column. But in the numerator, whichever variable you're solving for, you kick out that coefficient. So I'm kicking out the x coefficients. I am replacing them with the constants, keeping the other coefficients. Does everybody see where I'm getting those? Okay, and then we just simplify that. So it's 38 times 1 minus 6 times negative 3 over 2 times 1 minus 5 times 6. Okay, so that's 38 plus 18 over 2 minus 30. And that's 56 over negative 28 is negative 2. Okay, so y is a lot quicker because the denominator we already know is negative 28. So all I really have to do is figure out that numerator and put it over negative 28. Okay, the numerator, I use the x coefficients. I do not use the y coefficients. I kick them out and replace them with the constants. And then we simplify that numerator. 2 times negative 3, subtract 5 times 38 over negative 28. Negative 6, ooh, let's see, 5 times 38. 190. Okay, that's negative 196 over negative 28 is 7. So I have x is negative 2, y is 7, so that gives me the solution, negative 2, comma 7. What do you think?
Cool.
Pretty easy? Does anybody have a question on that? Okay, well let's take that same process and apply it to a 3x3. Alright, so you can see up here at the top, there's rules set up. Notice that these constants are in the x column when you're finding x. They're in the y column when you're finding y. They're in the z column when you're finding z. So they just do the same exact thing that we just did. They just move along and replace the coefficients that you're solving for. Okay, the denominator is always your coefficients. All right, so let's set up x. Okay, so denominator, all the x, y, and z coefficients. Be sure you're not missing any negatives. Okay, then the numerator. If I'm solving for x, I do not use the x coefficients. In their place, I'm using the constants. Keep the y's. Guys, do you have a question? Like that. Now, if you prefer to do this by hand, make your 2 columns and do the diagonals, you can. But let's just use our calculator to really quickly crunch these determinants out. All right, let's do this. Let's say if you're in these 2 rows over here, you find the numerator. And the rest of us will find the denominator, and then we'll share answers. Meaning what? Then that makes a difference. Think of your first column as the x's, your second column as the y's, and your third column as the z's, and you have to stick to that pattern. Okay? All right, so find your matrix. Remember how to do it. I'm going to go to Edit. I'm calling mine A. Enter the dimensions of it. Okay, then once you have your matrix typed in, go back to the matrix menu and go over to Math. And that's where you'll find determinant, DET. And then you have to, of course, tell it which matrix you want the determinant of. Okay, who needs help? You know?
What do I click at?
Who else needs help?
What do you do after you put it in?
Okay. Quit. Go back to matrix. Over to math. DET stands for determinant. And then you have to tell it which one. Go back to matrix. Did you call it A? Okay, what did the numerator people get? What did you guys get up here? Does everybody agree with that? Okay, we guys over here and one lady got 140, yes? Okay, so let's do negative 700 divided by 140 is negative 5. Okay, so when I set up y, I needed the 3 by 3 for the numerator, but I know the determinant on the denominator will be 140. So I don't have that work to do again. Okay, so let's set it up. First column is x, keep the x's. Second column is y, don't use the y's, use the constants in their place. Third column is z, use the z's. And then we'll go to the calculator, find that determinant, and we'll have our y. Do you like this better than the substitution elimination? Okay, so I'm not going to say anything. See if you can remember how to set it all up. Anybody need help? Any questions on getting Y? Check up here once you have it. Okay, I'm going to go ahead and set up Z then. So to find Z, I need a 3 by 3 over 140. Okay, first column is X's. Second column is Y's. Third column is Z's, but I'm solving for Z, so I don't use the coefficients. I use the constants in their place. And then let's find this one. See if we get the same thing. I feel like there's less room for mistake as opposed to the substitution and elimination method. Are we good? Does anybody need help on the calculator? That's today's lesson. Cool. All right, I will give you your homework. Those of you who need to finish the quiz, I will hand those back out. And you have so much time left.